Welcome everybody, welcome along this evening again to the Northeast Region Engineers Ireland event, Introduction to 5G. Thank you all for registering and for coming along this evening for this event. And I'm delighted to welcome our guest speaker this evening, Owen O'Donnell. So Owen is responsible for marketing, strategy and new product introductions in VIAVI's wireless business unit, with a particular emphasis on virtualized 5G radio access and core network testing. He's principal contributor to the company's test suite for 5G and O-RAN specifications. And Owen has more than 30 years experience, although he doesn't look at it, in the telecommunication industry, having worked at Ericsson and Huawei, and has lived and worked in Sweden and the UK prior to settling back in Ireland. So we're delighted to have Owen present to us this evening. The talk will take about 35 minutes or so, on 35 minutes. If anybody's any questions, at the bottom of your screen there, please use the Q&A function and log your question. And I think you can ask questions as you go along. We'll save some time at the end to cover them off. And that's really it. So I just like to thank Owen myself for coming along this evening, and I'll now pass over control to yourself, Owen, to take it away. So over to you.
Perfect. Thank you, Barry. And thank you very much for the invite and the opportunity to present. Let me just, am I mute? No, I'm not mute. Can you see my screen?
Yes, we can hear you.
Okay, perfect. All right, let's kick off then. So as Barry said, I work for a company called VIAVI. We're based in Dunleary here in Dublin, and I'm marketing manager. Now, I don't profess to be an expert in 5G, but my job does involve 5G test equipment and meeting and discussing 5G testing with equipment vendors, mobile operators and universities, research centers, etc. So I do have a good grasp of 5G and specifically the use cases that it will enable. So this evening, I will present some information to you with a mix of content from technical to high level and plenty of graphs towards the end. So at the end of the presentation, I'll be happy to take questions. So if you want to hold them till then, I don't mind the odd one interrupting, but it might help the flow if we keep most until the end. So agenda-wise, I'm going to give a little discussion on mobile evolution, because we are at 5G. So obviously we got to 5G by going through 1, 2, 3, and 4G. Also, I'll then move on to what is 5G and talk about 3GPP and spectrum. Then I'll give a little bit of 5G terminology. I'll move on to 5G architecture, some of the use cases which you're going to hear about, and then a little bit on deployment status. And finally, I'm going to debunk the COVID myth about 5G. And then we'll see if there's any questions and answers. So let's go on to the next slide, which basically introduces the different Gs before 5G. So 1G was mobile telephony back in the 80s, which was based on an analog system. And it was basically just voice calls, and it was on a phone attached to a briefcase, and it was rather clumsy, and not many people had them either. But it was 2G in the 90s when we started to seeing real mobile telephony take off. And this was introducing something called GSM, which was using digital communications for mobile telephony. 2G was quickly enhanced to 2.5G when we introduced stuff such as data and SMS and email with the technology called Edge, which was 2.5G. Moving up to 3G, which was in the year 2000. And it was 3G that heralded the arrival of decent data streams with speeds of up to 2 megabits per second, and the launch of 3G, also called the UMTS. And this focused on video calls as being the killer app. In fact, it was now that the mobile company 3 launched and are still going. Also, the iPhone was first launched in 2007, ready for the launch of 3G. So smartphones with apps took advantage of these enhanced data rates. And then we moved up to 4G, which is around 2010. And you'll notice that the time between each generation is approximately 10 years. And that holds also for 4G, which came out in 2010, also called LTE. The biggest enhancement really from a user point of view was the data rates, which was now reaching 100 megabits per second. And new phones and subscriptions were being sold with free TV streaming services such as Sky Sports to show off the ability of streaming on the move. And continuing the 10-year evolution, we now arrive in 2020, well, we did a year ago, with 5G, which I'm going to talk about this evening. By the way, mobile evolution is continuing, and we will have a 6G in 2030 and a 7G in 2040. So this is something which will continue and continue, which is good for people in the industry like myself. But if we look a little bit more at mobile communications, so it's really a commodity now. Before we go into 5G, I expect you would all agree that mobile communication is like electricity or running water or gas or Wi-Fi. You take it for granted that it will work when you need it. And the only time you look at your phone or your settings or your signal strength or the number of bars is when something goes wrong. I mean, we make calls, we browse the internet, we send WhatsApps, we check Twitter, we use Facebook, we FaceTime our kids whenever we want to, and it nearly always works. We move into and out of Wi-Fi coverage from home to the macro mobile network when we leave the house on a Teams call. And we may notice a 2-second blip as the connection hands over, but that's fine as it always comes back. So the point I'm getting to here is you probably won't notice when the 4G symbol at the top of your screen, circled there in the green circle, you probably won't notice when that becomes 5G on your phone because it won't make a huge amount of difference to your daily activities. You might notice a Netflix movie downloads quicker or a large email opens sooner, but how often do you do these things outside the home or office? So 5G is not really aimed at improving your daily mobile tasks, but more at new use cases and opportunities for mobile network operators to make new money. So 5G networks will gradually introduce us to a set of new technologies, use cases, and opportunities for mobile network providers to increase their revenues. And terms like Cloud RAN, virtualization, software-defined networking, multi-access edge computing, massive MIMO, URLCC, CUPS, V2X, beamforming, network slicing. These are all terms you may have heard of, but are all relevant to 5G. And I will mention some of these in the coming slides and try and demystify what some of these terms actually mean. So if we look then at 5G, and also I'm going to talk about who are 3GPP and what spectrum 5G will reside on. So 5G, it's a specification to start off with. So this is very important as it needs to have guidelines, ways of working and interworking. The body responsible for writing the specification is called 3GPP, and that stands for Third Generation Partnership Project. It was formed in 1998 in time for 3G, when ETSI and other standard, ETSI being the European telecommunications body, when they and other standard development organizations from around the world came together to develop a worldwide technology. Now, prior to this, Europe had its own mobile standard, as did the US, so moving around the world was not easy with your mobile phone and your subscription. So 3GPP was brought together, and they have a release now called 5G, which is released in different versions or release numbers. So release 15 was introduced in June 2019, and that introduced the new air interface called New Radio. And there's two types of New Radio. There's non-standalone and standalone, which I will talk about later on, but there's two ways of introducing 5G, and they're the two terms that we use. Release 16 of 5G was released in July last year, and that focused on some of the new 5G applications, such as URLLC and eMBB. Again, I will talk about those in a moment. And again, 5G is continuing to be worked on, so there are more work items being worked on, and they'll be released in release 17, which should be sometime around midsummer of this year. So it's a continuously evolving standard, but it's good news that there is a standard so that the likes of Ericsson, Nokia, Huawei, and Samsung, all the companies that develop base stations, they need to comply to this standard. Otherwise, then there wouldn't be compatibility when you move from country to country or even from cell to cell. Now, when it comes to the standard itself, this is an example of one of the many specification documents that 3GPP produce. So this one would define many of the functions a base station will perform in its daily operations of handling a mobile phone. So registering a handset, authenticating it, setting up a data session, paging the handset, handing over, all of those activities that the base station does are defined in this one document here. But this specification alone is 329 pages, and there's a lot of specifications. So there's a huge amount of work gone into the production of the 5G standard. But as I said earlier, all the handset providers, the Apples, the Samsungs, the Huaweis, they must comply to this standard so that we can have a system that allows different phones work on mobile networks and made up of different vendors as well. And a little plug here, the company I work for, VIAVI, we're responsible for ensuring that the equipments that the Ericssons and the Huaweis and the Nokias produce, that they are compliant against the spec. So that's why we have a vested interest in this area. But if we move on to what is 5G. So as I mentioned at the beginning of the presentation, 5G is just an evolution of the mobile communications generations, but it has been defined as having or requiring to have spectral efficiency, better spectral efficiency than 4G, lower power consumption than 4G, higher multi-gigabit per second speeds, ultra low latency, which is the amount of time it takes to send a signal, more reliability, massive network capacity, and increased availability. So these were all the proof points that they said we want 5G to be before it's launched. Now, all of these do give rise to new use cases, which were not possible without some of the or all of these facets. And that's what I'll talk about when I talk about the use cases. If we compare 4G to 5G, you can see the 4G column in the middle and 5G on the right-hand side. And I've just highlighted a couple of the differences that are notable when it comes to 4G performance against 5G performance. So you can see that the user experience data, so this is what you and I using our mobile phone out in public might experience. So on 4G, we might get around 10 megabits per second of download speed. And 5G, that's expected to go up to 100 megabits per second. So there's a huge increase there. Latency in 4G is around 10 milliseconds. In 5G, it's 1 millisecond. And that latency improvement is one of the platforms for this ultra reliable, low latency type of use case, which is really big killer application for 5G. And then the third one I'm going to show you is connection density. So in 4G, you could have up to 1,000 devices per square kilometer. But in 5G, they want to bring that up to 1 million devices per square kilometer. So this is where we want to bring in a huge amount of these smart meters and sensors and basically give a 5G SIM to huge amount of devices sitting in our network, which can then connect to the network and send small amounts of data regularly. So they're just some of the big differences between if you compare 4G to 5G from a user point of view. If we go on to look at the frequencies that are used in 5G, so there's roughly 3 frequency bands. One is down around the 700 megahertz range, which gives very good coverage because these are TV broadcast frequencies. However, they're prone to interference, and there's also not too much spectrum available at these frequencies. So that doesn't give rise to a huge amount of opportunities for the providers. The second band is around 3.5 gigahertz range, and that's similar to existing mobile systems frequencies. So this is ideal for something called massive MIMO, or using a lot of antennas where you can have large amounts of data because you've got a huge number of antennas to receive that data and transmit it. And then there's also a third frequency range, which is called millimeter wave band, and that's up around the 24 to 28 gigahertz frequency range. So those would be the frequencies earmarked for 5G technology. Now, looking at those again, if we compare two of them, one is sub 6 gigahertz, which is under 6 gigahertz. The wavelength of the frequency here is between 1 meter and 10 centimeters. And this is quite a congested spectrum. So existing mobile technology and cheap equipment and deployment is much easier are the advantages for using these frequencies. And then up around the 37 gigahertz range, it's called millimeter range, because the wavelength of the frequency is down to 10 millimeters to 1 millimeter. So that's why it's called millimeter wave band. And there's a lot more free bands up in this area. But the only problem with millimeter wave band is it's subject to greater path loss. You have higher noise content. There's less penetration through walls and windows. So to overcome these deficiencies, mobile operator planners are using smaller cells where the distance from the base station to user is much less. So you can deploy a lot more of these cells in inner cities, for example. But of course, before you can build out a 5G mobile network and offer your service, you must first need permission to use these frequencies. And that's done through government auction. Now, here in Ireland, this is an article from 2017 showing the results of the 5G spectrum auction which took place. And 5 companies bid for the spectrum in the 3.6 gigahertz band. And in the process, the government actually made 78 million euros for basically allowing the air to be used for mobile communication. Now, the big 3 well-known mobile operators were there, Vodafone, 3 and Meteor, as well as 2 new entrants. One is Imagine Communications, which I'm sure some of you have heard of. They obtained spectrum in each of Ireland's rural provinces. And Airspan Communications, or Airspan Spectrum Holdings, as they're called, which is a new entrant to Irish market, focused on smart utilities and public safety. So this is an example of how our frequencies are auctioned and who wins them and how they pay for them. And then once they have these frequencies purchased, then they can go and start rolling out 5G equipment and offering a service to their subscribers. Okay, let's move on to terminology. So these would be some of the technical terms bandied about in the industry, and I'll try and demystify a couple of them. So here are 5 terms which you may have come across and are all arising out of 5G. So I'll quickly describe each one, beginning with the last 3, because they're often grouped together as 5G killer apps, and they are URLLC, MMTC, and EMBB. So if you put them, 3 of them in a triangle, enhanced mobile broadband, that's basically huge amounts of data transfer. That's all that means. And the way you'll see this if you're a user is it may currently take a minute to download a movie, but with 5G EMBB, it'll take seconds. So that's basically the way you can prove that you are running on a 5G network. Now, the attributes of EMBB are high throughput, but limited movement of user. So it's perfect for home broadband. And that's an ideal use case, in fact, for EMBB. It's called fixed wireless access. So it's an alternative to fiber to the home. At the moment, I think 50% of the world's population is still waiting for reliable broadband access. So that represents a huge problem to mobile operators. Sorry, a huge opportunity to mobile operators, because they can deploy 5G in those areas and have an antenna on the side of the house which receives the 5G signal, and then a small wire connected inside the house to a modem or router where they can deploy Wi-Fi inside the house. So you do not need fiber to the door for this solution. And this is where Imagine come in. So Imagine, who are one of the The winners of, or one of the purchases of those 5G frequencies on the previous slide, that's what they're planning to do with those frequencies, is deliver home broadband over 5G to houses in rural Ireland. So another use case is massive machine type communication, or MMTC. And this is basically enabling millions of devices to communicate with the mobile network. Now, the attributes of MMTC are low cost, long battery life, and enhanced coverage. So ideal for smart grids and sensors. And then the third big one is this URLLC. Now, this is kind of refers to mission critical stuff, and this is the sexy new stuff that you may have heard of, such as remote surgery, or virtual reality maintenance, or V2X, self-driving cars. Basically, all of these applications are coming on stream now purely because of URLLC and very short latency. And one example which might hit home with you is if a car brakes suddenly 300 meters in front of you in thick fog, you need to be alerted in fractions of seconds, not 10 seconds. And that's where URLLC comes in. So having this low latency, or if you like, very quick turnaround of signaling, then that will alert your car to this occurrence happening in front of you, and you can take alternative action. So one slide on each again, just to hammer them home. So EMBB, which is enhanced mobile broadband. So this can be achieved through two ways, actually. Before 5G, which is the new base station here, G-Node B, before 5G is fully launched in the country, you can actually use the existing 4G technology, which is already installed. So the way it works is you have a base station called a 4G base station and a 4G core network. And the UE, the mobile, connects through that system to the network. But then the base station, the 5G base station, can actually supply a lot of the data to the UE, or to the mobile phone. So it's like a hybrid version of 5G, but it suits mobile operators who don't have full 5G coverage in the entire country. So they can partly launch 5G by already piggybacking on the 4G system. So that's one way of launching 5G. Massive machine type communication. So this is again where you have, it's designed to provide a cheap and robust simultaneous connections to billions of devices and modules over wired or wireless networks without overloading the network. Now, devices like monitoring sensors, execution control units, connected home appliances, smart lights, basic wearables, all of these things can be now connected to the network. Before they weren't connected. And massive machine type communication allows for automating of various processes, for reducing the need for human interaction, increasing efficiency, reducing costs. So all of this is now being enabled by 5G by introducing this type of use case, which is MTC. And then the biggest one and the most interesting is URLLC. So this is defined by 3GPP, which is the standards body, as user plane latency of 1 millisecond or less, and control plane latency of slightly higher. The difference there is user plane is your data, control plane is your signaling. And reliability, of course, is capability of transmitting a certain amount of data within a time duration and high probability of success. But you can see in the bubble here, these are some of the use cases which will take advantage of URLLC. So you've got professional audio, you've got self-driving cars, you've vehicle-to-vehicle communication, industrial automation. So all of these will start coming on stream only now because we have 5G and we have this URLLC use case, which 3GPP have said is extremely important. Okay, let me move on to the last two points that were in this chapter, and that's massive MIMO and beamforming. So Massive MIMO is basically about putting loads of antennas into the base station and also into the mobile phone. So in regular MIMO, which is something we have today and something you might see on the side of a building, you would see a long rectangular white box, which is the antenna. And inside there might be 6 antennas, 3 transmit and 3 receive. But with massive MIMO on the right-hand side here, you're going to start seeing antennas with huge numbers of antenna inside, maybe 6 by 6, which is 64 antenna elements could be in one box on the side of a building. And from these antennas in 5G, you will have a much narrower beam transmitting to the phone or to the UE. And that beamforming is much more efficient, much more accurate, can give a much higher throughput and also less interference. So that's a big change from 4G to 5G with this massive MIMO and beamforming capabilities, which is something that will help with comes to data rates and also user efficiency. Okay, let's move on to 5G architecture. So just 2 slides here to try and give you an idea of how 5G would look. So the 5G radio access is shown here with the 5G base stations called G-Node Bs, processing the calls from the mobiles in their vicinity to the 5G core network. Now, the base stations also communicate between each other using an interface called XN. And the base stations communicate with the core network over other interfaces called N1, N2, and N3. Now, all of these interfaces are defined in the 3GPP specs, so they're something that the base station vendors need to comply to. So as 5G is completely specified in the standards document from 3GPP, then all the signaling and all the messaging between the base stations and each other and the base stations and the core network is outlined very clearly so that a mobile operator can deploy one base station from Ericsson, another from Nokia, another from Huawei, and feel safe in the knowledge that they all speak the same language when communicating with the mobile phones and the core network. So, for example, if Vodafone are looking to launch 5G in Ireland, they'll first of all need to obtain spectrum from the Irish government, which I showed in an earlier slide. Then they need to purchase brand new 5G base stations from the likes of Ericsson or Nokia or Huawei. Then they need to deploy a brand new core network in a data center. Again, that could be from Samsung, or it could be from Ericsson or from Nokia. And finally, they need their subscribers, that's you and I, to upgrade to a handset capable of running 5G technology. So all of those things need to come together before you can have a 5G session. Now, one other very interesting area that 5G is giving rise to is something called Open RAN architecture. So this basically started as a result of operators, mobile operators, not wanting to be locked in to 1 or 2 base station vendors. So they initiated a change in the BTS and the base station architecture, where they proposed a split of the base station into separate functions. So on the left-hand side here, you can see a traditional base station, which is something you see on the side of the road. Now the right-hand side is that same base station, but broken up into several elements, something called a CU, a DU, and an ORU. Now the purpose for doing this is that you can now have dedicated new companies developing each of these individual elements and selling them to the operator, which means there's a much bigger ecosystem or vendor supply chain. So the operators can pick and choose who they want to purchase from, and this will lower their costs. So that's really the reason why this was introduced. And all of these elements need to comply again to standard interfaces between them so that they work when they mix and match vendors from different components. In fact, there is one company here in Dublin who's entered this market, and they are manufacturing these ORUs, which are radio units. And the company is called Benetel. So a nice little shout out to them. Okay, so let's move on to some use cases. So I'm going to dig a little deeper into use cases, as these are probably the most interesting aspect of a new mobile generation. and where we likely will see the most innovation and startup companies appearing. So this list basically is just starting and will be added to. So you would say that many current services that you might come across, they're just merely better on 5G, which is something I said at the beginning of this presentation. What you see on 4G, you will see slightly better on 5G. But advanced kind of only on 5G experiences, they'll only become on mainstream once infrastructure develops and handsets supported and new services are launched. So you might see something like, AR experiences for sports fans. You might see fixed wireless access services to home. You'll see connected cars. You'll see automated driving. You'll see something called network slicing. So these are all applications or use cases which will be enabled by 5G, and you're going to see very soon. So let me just talk about a couple of those in a bit more detail. V2X, smart factories, and network slicing. So these three will impact all of us in the coming years. And many of you on this call may well be affected by these because they affect anyone who drives a car, anyone who works in a factory, or anyone who performs surgery on patients over 20 kilometers away. Well, maybe not the last one, but the first two will definitely impact most of us. So if I just go into V2X for start. Now, V2X, this is actually very interesting, and some of you may have come across this already. But what this is, so it's a comprehensive road safety and traffic efficiency solution that allows vehicles to communicate with other vehicles, so that's V2V, vehicles to other pedestrians or cyclists via the smartphone in their pocket, that's V2P. The car can communicate with road infrastructure, that's V2I, or it can communicate with the mobile network, V2N. So V2X means, the X means many things. So it could be one or many of these elements that the vehicle is communicating with. And the whole purpose of this is to increase safety of the vehicle driver. But why the need for V2X? So here are some startling statistics. So more than 1.25 million people die each year as a result of road traffic crashes. Between 20 and 50 million more people suffer non-fatal injuries and disability as a result of their injuries. And road traffic crashes cost most countries about 3% of their gross domestic product. Now, just to put that into perspective, Ireland's gross domestic product in 2019 was $388 billion. So 3% of that figure is $12 billion. So that's how much money is spent as a result of road traffic accidents in one country alone. So there is a body called the 5G Automotive Alliance. I've shown their emblem here on the top right. And their purpose, they've been formed with the sole purpose of bridging the automotive industry, that is the car manufacturers and the road authorities, as well as the telecommunications industries. So bringing those together in order to address the connected mobility and road safety needs. And this is great because 5G allows this. 5G technology has allowed us finally get to this point. So these would be some of the example use cases for V2X technology. So it could be something as simple as like a traffic light countdown on your dashboard. So you're sitting at the traffic lights and there's 10 seconds left before the lights change to green for you. So your actual dashboard will start counting down audibly 10, 9, 8, and that gives you plenty of time to get in gear, put your phone away, stop talking, and be prepared to take off. That alone is an efficiency improvement. It might not be a road safety improvement, but it's an efficiency improvement. But then you could have hazardous warnings of conditions ahead. So you could warn the car that there's a hazardous location ahead and provide additional information to safely navigate around that hazard. So this picture here, for example, shows a massive car crash in freezing fog, where cars didn't have time to stop and couldn't avoid going straight into the car ahead. But V2X technology would have warned those cars that there is a problem ahead. You need to brake now and try and stop safely. Third one here, sudden braking of the car in front. So again, you can be alerted that the car ahead of you is undergoing an emergency braking event. That can come up on your dashboard. A pedestrian in the road, so a pedestrian or bicycle in the road, you can be alerted in your car that there is, through the smartphone in their pocket, that there is somebody in the road. It could be dark, could be fog again, and you wouldn't see them. A couple of other interesting use cases. Platooning is one, which is it's like many trucks together on a highway or on a motorway, and they actually move like a train. They move with very small distances between them, because of the V2X technology, that keeps them at the same distance, moving like a train basically along the motorway. And that can reduce fuel consumption, it can reduce gas emissions, and also transports them in a safe and efficient manner. And then there's overtaking, there's traffic jam, there's intersection risk. So there's a lot of use cases that V2X has, again, all enabled by 5G. The next one is smart factories. So smart factories is another word for smart factories is something called Industry 4.0. Again, it's one of these numbers. So industry has been categorized into 4 different evolutions. There was 1.0, which was mechanization through water and steam power. Then there was 2.0, which was electrification through mass production and assembly lines. 3.0 was digitization using computers and automation. And now 4.0 is next. This is where 5G comes in, and 5G will provide connectivity. It'll provide smart, autonomous machine learning, massive data exchange, etc. All because we have the ability with 5G. Now, a bit similar to the previous one, I've put another logo here on the slide showing 5G ACIA. So this was a forum which was brought together, and their objective is to ensure that the best possible applications of 5G technology and connected industries can come together. So they're making sure that we have this smart factory ecosystem taking off, but using 5G to enable it. And so on the previous slide with 5G AA, on this slide with 5G ACIA, and both of these have been born out of the need to ensure 5G is used correctly for 2 different industries. This is just a picture of how a port, for example, might be enhanced using private 5G or smart factory or smart factories basically. So some of the elements shown here, for example, you could have AR guided execution. This is with your reality glasses, where you can guide what's happening through remotely. You can have real-time inventory. You can have reliable robotic control. You can keep all of the data locally rather than having to send it up to a data center, which keeps protection and sensitive data on premise. You can have autonomous AGVs, which are automated guided vehicles. So all of these can now be enabled in, for example, a port or a factory based on 5G, because they're all using wireless telecommunications and not fixed wires or Ethernet access. And then the last one use case which is of interest is something called network slicing. So this is a new term that's specific to 5G, and it's a much bandied about use case. So it's a bit like having a police escort for your specific data session through the mobile network. Now in the diagram, you can see again the same 3 use cases of eMBB, URLCC, and MMTC. So these would be considered different types of slice which you would have through the network. So for enhanced mobile broadband, that slice is, for example, a large video being downloaded. Now, the way to handle this efficiently is to have a local cache of that video so that you don't have to transfer huge amounts of data all the way through the network. This cache then is placed as close as possible to the user to keep the transmission and the latency down. The URLLC slice, again, which could be a car, something that requires low latency. So then the most important element here is to keep the parts of the network you need as close to the user as possible. So you can see they've all been moved down to the edge, and then you have very little latency between the network and the user. And then the sensors are the smart meters. Then for these, this is the MTC slice. The important part here is that you don't need a huge amount of core network capability. So you have a lightweight core when it comes to managing these slices. So you can see different architectures require different amounts and resources in different parts of the network. And it's this flexibility which allows us to introduce network slicing into the mobile operators' networks. Now, one note of caution for the operators here is that network slicing, it's a way of kind of guaranteeing that a data session will be maintained at its maximum performance for the duration of the session. But that's a bit like a contract being made with the subscriber. So they will pay extra for this, and the mobile operator will need to ensure it works. So that's something which we will start seeing coming on stream very soon. Okay, I'm just keeping an eye on the time. I think I'm moving on nicely. Yeah, only a couple of sections left. So if we now look at the deployment status of 5G, where we're at, and for this, I'm actually going to use a couple of graphs, which I'm grabbing from my own company, since we produced a state of 5G infograph in the last week. And you can see here that 5G has been deployed now in over 1,336 cities across 61 countries. Now, the latest countries to deploy 5G are shown here in the Americas, in Europe, and APAC. But you can see basically that we are now having a huge amount of 5G deployments. Some of the top countries who you might expect to be leading are shown here on the left. You can see that it's the Far East with China and South Korea who are deploying most 5G cities, with USA coming second in between them. And then you've got UK, Spain, Canada, all these countries with varying amounts of cities deploying 5G networks. And then from a regional point of view worldwide, you can see Asia again is leading the way when it comes to how many cities are deploying 5G. They were first to deploy it, with Korea and Japan and China being the first out of the blocks when it comes to 5G rollouts. And then the last slide on this is just showing you the increase compared to last year. So last year, about 378 cities had 5G deployed. But now in this year alone, and we're only a quarter way through, we're up to 1,336. So that's like 958 new cities deploying 5G. So it is taking off. And we're starting to see huge ramp up of 5G, and those use cases that I mentioned, they will start coming on stream as more 5G deployments are increasing to be brought to us. Okay, if I just then one slide on debunking the COVID myth. So this was something which was not nice to see about a year ago, when people thought there was a correlation between COVID and 5G being deployed at the same time. So just to kind of show you some research that's negating this. So these are just some of the points which I've come across. So first of all, most of the electromagnetic energy that people are exposed to comes from their cell phone and not the base stations. Now, a denser network means that the cell phone does not need to transmit signals with as much power, because the base station is closer to you. Your cell phone can ramp down the power, therefore exposing the user to even less radiation rather than more, which is the case with people taught with 5G. Also, then when it comes to the different frequencies of radio waves, the radio waves 5G is operating at are very, very much less than those we're already exposed to in light. And the strong consensus basically of the WHO and Public Health of England is that no health risks have been established from the exposure to low-level radio signals used for 5G communications. So hopefully that will put your minds at rest. Right, I probably ran through those slides quite quickly, but I am coming to the end, and I'm happy now to take questions if there are any. I haven't been looking at the list coming through. Barry, I'm not sure if we have any questions.
Yeah, is anyone any questions they want to ask on now? Just give them check any coming through. Owen, first of all, can I say thank you for that? That was extremely interesting, and it was at a level that someone like myself, thankfully, could understand most everything you were talking about. So very, very
Good.
nice position for, I'm sure, for everybody else on the tonight's session as well. It was very good. So thank you again for that.